back to day 2 of our topic of percentages. We're going to expand a little bit upon what we did yesterday. Yesterday may have felt more like what you probably learned in your past studies. This is something you may not have seen before, and it's actually a really useful tool. I've used this formula in my day-to-day life, and I know you're probably thinking, oh, she's a math teacher. Of course she does. I use this actually when I'm tracking my finances. So things that I do for my personal life, this comes in really, really handy. So something really practical for math that I think you can really take with you as you make decisions in your adult life. So I feel like this is one of the things I really like about this course. So what we're going to talk about today is talking about what's called absolute and relative change, not only in terms of something that happens over time. So for example, you want to track how much savings you have this year compared to 10 years ago or whatever it might be. This is really useful to see, hey, has what I'm saved gone up? Has it gone down? Do I need to make a decision that changes based on what I know? So this is really handy for something that you might use like in your own personal finance realm once you start making money and getting that paycheck. On the back of the notes, we're going to talk about something called absolute or relative difference. That the formula is going to be pretty much the same. The only difference is instead of tracking something over time, what it's going to do is it's going to compare two different things. So in this maybe the same frame of time, but I'm going to cost compare cars or something like that. It actually is comparing something tangible versus something over time. So in the front, we're going to talk about comparing something over time. The back is going to be comparing two different things. Okay, so let's get started with how we're going to use this formula to help us with those things. So the formula for relative change, which is going to track something over time, is you'll see it right here. This is the formula that you're going to want to use on all of your questions that have to do with relative change. Okay, let's just break down what all those pieces are. So those up here, you'll see what we're talking about when it comes to some of these pieces. So a reference value is a starting number. So this is a starting number. So for example, you want to see how much you saved in 10 years, like I said before. Okay, well, the starting number would be what you had 10 years ago. Okay, the absolute change is going to be, let's say we talk about money again, it's going to be what is the actual dollar difference in dollars, not percent. So say I had $100 10 years ago and now I have $1,000, I would subtract those two numbers and I would get a $900 value. So these are going to be just a value and not a percentage. So this is going to be the actual, oops, this is going to do this a lot this year, so bear with us. Just something about writing in Word, I don't know why it does that. The actual increase or decrease from the reference value, so that's starting number, to the new value. So what do I have today in terms of money? Or what is the population now versus what it was 10 years ago? Okay, so this is going to be a little different than relative change, which is the formula you'll also use, but you'll notice that they're really, really similar. The only difference you'll notice between this absolute change formula and this relative change is now you have a denominator here and you're going to multiply it by 100 to make it into a percent. Okay, so relative change is the size of the absolute change in comparison to the reference value. So what this is going to do is it's going to, I lost my E there. What this is going to do is it's going to tell you like what percentage it went up by or what percentage it went down by. If you get a positive number, that means something is increasing. If you're going to get a negative percentage, that means something's going down. It's decreasing. All right. So here's an example. This is in terms of population. So let's say in the last 20 years, Addison's population has increased from 34,092 to 36,724 residents. Obviously, you can see it's going up, right? What are the absolute and relative change in population? So the absolute change is going to be the total number of people that it went up by or down by, and as we just said, it went up. So we're going to start with what we call our new value, which is how many people are there now? Okay, and this is our old value or our reference value, because that's our starting number. So the formula for absolute change is new value minus reference value. So all we have to do is say, all right, this is our absolute change. It absolutely went up by 2,632 people. So the village of Addison has grown by that many people in 20 years. Okay? So when we look at relative change, and this is something I find relative change to be much more meaningful because it gives you context and it puts things that are maybe like different quantities on the same playing field when you see them as percentages. So what we're going to do is we're going to take this value. If you look at your formula, that's this top part of the formula for relative change. So we're going to take those and we're going to put them in our formula. And if you'd prefer, you could just take the 2,632 and put it on the top because it is the same number. Now we're going to divide it by the original number or the reference value. So we're going to say divided by 34,092. And then once we get that number, we're going to multiply it by 100% to make it a percent, like we talked about the other day. And that's going to be our change. So you're going to want to go ahead and subtract these first. We already have that number there. Divide it by 34,092. Hit enter, and then multiply by 100. And you should see that there is a 7.72% increase in population. Okay? So that is absolute change and relative change when it comes to a population example. So if the village of Addison saw that, they'd be like, maybe we need to have more housing. Or maybe we need to make more room in the schools because our population has gone up so much in the last 20 years. So you can use that information to make a decision about something. Okay, so the next example is something that happens a lot. I've noticed it a lot when I bought a car that the value of it will go down so fast. So this is happening with the digital camera because obviously as technology changes, the thing is going to be worth less when it's an older model. So it says a digital camera that you purchased 2 years ago for $800 is now valued at $368, although you still consider it valuable. Find the absolute and relative change in the digital camera's value. So this is actually something that comes in handy when you're trying to sell something to somebody else. Like if you have your old iPhone and you want to sell it, you want to know okay, how much has it gone down by, so I know what's a good price to get for what I'm trying to sell. Okay, so let's go ahead and look at the absolute difference. And by the way, this is going to be a negative number because you'll notice that the reference number, which is the beginning number, is much bigger or much higher than the new value. So we should see a negative on this one. So the absolute change is going to be, as you can see in your formula up here, let's go back and revisit. Okay, it's going to be the new value minus the reference value. So I've got my new value, 368 minus 800, and that means I have a negative quantity. It went down by, so it decreased by $432. Which is what tends to happen. You guys know that more than I do, that technology, since it changes so much, that's going to happen. That's not unusual. All right, relative change. Remembering that it's going to be, so the formula reads as new value minus reference value divided by the reference value now. So it's our 368 minus 800 divided by my reference value, and then multiplied by 100. Okay, so this one, yikes, this one had a bad one. You'll end up with about a negative 54%, which means that your camera that you find so valuable has decreased by 54%. Yikes. But hopefully you love it enough that you don't care. All right. Moving on. So this is one of the trickier questions that I know you're going to be asked at some point, so you might want to star this. This is an important problem. It's kind of confusing if you think about it. So it says if a population triples, then it has increased by what percent? A lot of people think when you see triple, triple means 3, so that must mean it's 300%, but I'm going to show you that it actually is not. So what I'm going to do is I'm going to use the formula on the front. Let's say I have a population, but I don't know what that population is. So anytime I don't know something, I can give it a variable. If I triple that population, that would be 3x. So this is my reference value, my original. This is my new value. And we're going to use that formula. I'm going to prove to you that this is actually not going to be 300%. So the relative change equals, I use my, so we're going to go ahead. I'm just writing it down here so we have room. So I'm going to do my new value, 3x, minus my reference value over my reference value. 3x minus x, well, that's going to give me 2x. And then I have my over x times 100. I'm running out of space. Okay. These x's, by the way, that's a multiply. These x's are going to cancel, which means I now have 2 times 100%. I should have given myself more space, so I apologize, which is 200%. So just be careful. You have to actually like go through the formula to realize like, wait a minute, it's not triple doesn't mean 3. I'm talking about percentages necessarily. So just be careful. Okay. Now, like I said at the beginning, even though this is going to look a lot like we just did on the front, the only difference is going to be, so we're now talking about relative difference. On the front, we talked about something called absolute and relative change. So relative difference and absolute difference are going to be when you compare two different things. Okay, so it's not over time anymore, it's comparing two different things instead. So it's going to feel like you're doing what you're doing on the front, except that instead of time, we're talking about two different actual things. So reference value is still the same. It's a starting number. So when you're comparing two different things, you got to think about like, what am I comparing something to? Like, what's that thing that I'm comparing something to? Something is being compared and something is being compared to. So we got to be careful when we read the problem. So this is very similar to the front. The absolute difference is the actual difference between compared value and reference value. Okay. So you'll see it's pretty much the same formula as the front. Relative difference is the size of the absolute difference, just like the front. Size of the absolute difference, except instead of saying absolute change, it'll say absolute difference here. Absolute difference in comparison to the reference value. So again, you're probably still like, I don't get why this is different, right? But again, we're comparing two different things. You can't walk and chew gum at the same time. All right, there we go. So let's take a look at this. So now we're comparing, instead of something over time, we're going to say, hey, let's compare a Mercedes to a Lexus. So say you're looking at these two cars, and I know these prices are probably not really close to what they are, but let's pretend they're used or something. So I have a Mercedes that costs $50,000, while a Lexus costs $40,000. And then it says, how much more does the Mercedes cost than when compared to, or then the Lexus? So you're trying to figure out, okay, what is being compared, like what are we comparing it to? We are comparing the Mercedes to the Lexus. So this is the reference value. This is the beginning, like, hey, we're going up to the Lexus and we're going to see how much different we are and compared to the Lexus. Okay, so we're going to do the same formula. We know the reference value. That would make the Mercedes the new value. And then we just use a formula like we did on the front. So if I'm looking for the absolute value, I would take my new value, which is my Lexus, is $40,000. Oh, I'm sorry. My new value is the Mercedes. I messed up. My bad. All right, so we're going to go 50,000. I was thinking like, this doesn't make sense. Because we know the Mercedes costs more, which means it is $10,000 of absolute value more. Sorry, absolute difference. I wrote that wrong. I'm back in another class. We're not doing absolute value here. absolute difference. So sorry if I threw you off there. All right, so it's $10,000 more. Let's bring you guys back to Algebra 2. Sorry about that. Okay, so it makes sense. The Mercedes cost, I mean, you could see that. We're just looking at the original problem. Clearly, the Mercedes cost $10,000 more. Now let's do the relative difference. Okay, well, that's going to be the same number here. So new minus the reference value, but it's going to be over the reference value, just like on the front. Times 100% because we're getting it into percentage. So when I do that calculation, I'm going to end up with, it is negative 20%. So when, oh, sorry, I'm on the wrong one. I'm like, wait a minute, that's still, no. So it's going to be 25, you should get 25%. I'm peeking ahead at the key here. So I get a positive 25%. So that means the Mercedes is 25% more than the Lexus. All right, so before I continue, I'm going to switch it around. So just think for a second. It now says how much less does the Lexus cost than Mercedes. So now we're switching the car order. This is now the reference value because we're comparing it to the Lexus to that. So this is going to be our new. Do you think, just, you don't, obviously you can't respond to me anyway, but do you think we're going to get the same percentage, even though you know it might be like less versus more? Are we going to get the same percentage? So let's find out. I'm doing absolute difference. Okay, so now we're going to switch. It's going to be 40,000 minus 50,000. Okay, so this is actually the same number amount, but instead we would have to say it costs, so the Lexus is $10,000. Now we say less. Okay, now we get to the relative difference. Let's see if that's also the same dollar quantity, but just less. So we're going to use our absolute difference. So our 40,000 minus the 50,000 divided by our reference value times 100%. Okay. Well, I have news for you. Once you plug that in, so you get negative 10,000 divided by 50,000, you're going to end up with negative 20%, which is not the same number as the 25%. So the Lexus is 20% less, because it's negative, than the Mercedes. Interesting way how percents work, yeah? They sometimes get a little confusing. Okay. So let's take a look here at our last example. And it says the life expectancy of Americans in 2020 is 78.93 years, and the life expectancy of Americans in 1980 was 73.7. So clearly medical advances are meaning that we can live longer lives, which is great. It says how much greater is the life expectancy in 2020 than in 1980? So we're going to talk about it in relative and absolute terms. So I actually don't, I'm debating whether I would want to call this absolute change or absolute difference, because we are comparing something over time. The only difference is we're talking about different population sizes. So that's why I'm going to stick with absolute difference here. But I kind of am juggling with this a little bit in my head, thinking like, I don't know if I'd rather call this absolute difference or absolute change, but we'll stick with absolute difference for now. Okay, so I've got absolute difference would be, what's my old quantity? So 1980 was a lot longer ago than now. So this is going to be my reference value, and this is going to be my new value. So we're going to say 78.93 minus 73.7 over my, well, actually it wants the absolute values, or absolute difference. So I'm going to go ahead, I did absolute value again, oh geez. It's going to take me a while to get used to not saying that. Okay, so when I subtract those, I have 5.23. So on average, we live 5.23 more years in 2020. And then we have relative difference, which is taking our absolute difference and then dividing it by our reference or our starting value. Okay, and then multiplying it by 100 to make it a percent, we would have 7.10%. So we live 7.10% longer than in 1980. Okay. Again, that probably has to do a lot with advances in science and in nutrition, and exercise, and all that good stuff. But anyway, hopefully I gave you a glimpse into how you might use this. Like I said, I use this in my regular day-to-day life when I'm trying to like figure out, am I saving enough? Are my investments going up enough? That kind of stuff. So it is something that no matter what you do in your life, you could really use it for something important just in your personal life. All right, I hope this helps. If you have any questions, please let us know.